So in this each and every example, determine whether each of the following relations are reflexive, symmetric, and transitive. We have to check for these three. Okay.
Yes, sir.
So we'll discuss that exercise. All right. So first example, relation R in the set A, which is 1, 2, 3, so on up to 14, defined as R equal to x comma y, where 3x minus y is 0. Like this, they will give relation. Relation they will give you like this. So this is when A is finite, then R is relation on set A or in set A, then it is finite relation. This is finite relation, first thing. Yes, sir?
Yes, sir.
Finite relation. So when it is finite relation, then it's easy. Yes, sir? No, easy to.
Yes.
Yes, so you can simply write what is R, you can write what is R, you know. So you take simply you take here y equal to what you can say, you see x comma y, simply you can write x comma y belongs to R for what condition? If 3x minus y equal to 0, yes or no? This is a relation between x
yes,
and y.
sir.
Y equal to 3x, yes or no? Multiple of 3. So
yes,
here what you can write here, 1, if you put 1, y is 3. If you put 2, y is 6, 3, 9, 4, 12. 5, can we put 5? X. In the place of x, can we put y? Sorry, 5.
Yes, sir. Okay.
If you put 5,
No,
what will
we
happen?
can't. It's not part of the set.
Yes, so then because here this is defined yes, in A, na? In A, defined on A or defined in A means what? Means from A to A. From A to A, yes or no?
Yes, sir.
When it is from A to A, then X also A, Y also A.
Yes, sir.
Like that. So Y also should be from A. So if you take X 5, then Y becomes 15. Yeah, that's, you understand, right? Now this is what is your set. Sorry, your relation. This is what is your relation. Okay. Now you have to say this relation. This relation is number 1, reflexive or not? Reflexive.
It's not reflexive, symmetric or transitive.
Okay, good. It's not reflexive or symmetric or transitive.
Yes, sir.
Like that, simple. No? Okay. Right. Now we'll go to second question. Relation R in the set N. That means what? From N to N. Okay, natural numbers to natural numbers. Defined as, how R is defined? Defined as x comma y with this kind of ordered pairs. What kind? Y equal to x plus 5 and x less than 4. This becomes finite now.
Yes, sir, even this is finite. Yes, sir.
Because you take 1, x1, y6. You understand? x2,
yes, sir.
y7, x3, y8. Okay. Because your x is less than 4, natural numbers less than 4 is 1, 2, 3. That's all. This is, you can say, number
So
1.
this is also nothing. This is not reflexive, transitive, or
not reflexive.
Or symmetric or transitive, no?
Second, not symmetric. Not symmetric because 1 comma 6 is there, 6 comma 1 is not there. Whether it is transitive or not. AB, BC is there, then AC must be there. That's a condition. Sir, Evala to 1, 3 is there, 3, 9 is there. What should be there here? 1, 3 is there. 1, 9 is not there.
Yes, so this is transitive.
Yeah, this is transitive. Yes, good. This is transitive because we have 1 comma 6 is there, 2 comma 7 is there, but 3 comma With 6 there is nothing. No, AB is there. BC is not there. All AB is there. BC is not there. Like that.
Yes, sir. Got it.
Okay. So next 3. What is example 3? Example 3.
The example 3.
Yeah. Sorry. Bit 3. Okay. Question number 1, bit 3. Bit number. Yeah, tell me. What is?
Sir, it's reflexive because every number is divisible by itself.
Good.
I don't. It's not symmetric. I don't think it's symmetric.
Okay.
And
Okay, reflexive. You told no reflexive. How do you prove?
Yes.
Reflexive. So set
so
is very
because if you
simple.
take any number, it's
Divisible
any
by
number is
itself.
divisible by itself.
Okay.
So,
Good.
but that's how we
How do
prove
you?
it, no?
Yeah. How do you prove? Is like this. For like this. For every x belongs to A. For every x belongs to A. Whatever. Because here you need not say 1, 2, 3, 4, 5. For 1 is there. 2 is there. Instead of telling that general, you can say generalization. What is the generalization? For every x belongs to A, x comma x belongs to R. As reason, this is as you can write, or for means because, as also. For x is divisible by x, or as you said, for every x belongs to A, x comma x belongs to R. For every number is divisible by itself. Every number is divisible by itself, as you said. Okay.
Yes, sir.
So therefore, reflexive.
Sir, it's not symmetric.
Not symmetric because you should give reason.
Because if A divides B, that doesn't mean B divides A.
Yes, you should give counter example. This is proof by counter example. Counter example. Counter example. Proof by counter example. Very important. Proof by counter example. Whenever you say no, you should give an example where it is no. Because if you say it's yes, you have to prove it. You cannot give one example where it is true. You understand what I'm saying?
Yes, sir.
If it's false, if it is not true, then you have to, because one example it fails, it is enough, right?
Yes.
And like this. See, why do we see x comma y? So that means what? 2 comma 4 belongs to R. As 4 is divisible by
2.
By 2. But 2 comma 4 comma 2 does not belong to R. Over as 2 is not divisible by 4. Like this, you have to give an example whenever it's failing. Is that okay?
Yes, sir.
All right. Next, trans2. What do you think about trans2?
Sir, I think it is transitive.
Good.
So because if we take 1 comma 2, like in this set in R, you'll get 1 comma 2, 1 comma 3, 1 comma 4, all of those.
Correct. But you see, how do you prove?
And then when you take 2 comma 4 also, you'll get 1 comma 4 again. So that way it is transitive.
But how do you prove, this one? Whenever you have to prove, I am telling you this important thing. Transitive. How do you prove it? Whenever it is transitive, you have to prove like this. See? First, let A comma B. Here x comma y used, so let's use x comma y only. Doesn't matter. But x comma y is already used. Let x comma y belongs to R and y comma z belongs to R. So first, let's assume x y is there and y z is there. This two. If x y y z is there, then what you should prove?
X comma z belongs to R.
X comma z belongs to R, you have to prove. Then it is transitive. Otherwise, it's not. Okay.
Yes,
So
sir.
that
So your voice is
implies.
breaking a little.
Oh.
Little, like occasionally.
So I don't know, some problem. It's a problem here.
So now it's fine. Just once or twice in between it's breaking.
Yeah,
Otherwise it's
once in,
completely fine.
yeah. So also computer is showing that your mic, your speaker is not working properly, but I don't know where to fix. Okay, anyway, let x comma y belongs to R and y comma z belongs to R. Here, what does it mean x comma y belongs to R? Y is divisible by x. है ना?
Hmm.
Y is divisible.
So we have to prove that z is divisible by x.
See, y is divisible by x and z is divisible by
Why?
y. Automatically, you see, y is divisible by x and z is divisible. Z is divisible by y is divisible by x. That means what?
So
Automatically,
x is divisible by, sorry, z
z
is
is
divisible by x.
z is divisible by y. That means what? Divisible means what? Z is divisible, multiple of y.
Yes, sir.
So y is divisible by x means what? Multiple of x.
Yes, sir.
So automatically, so that implies simply you can write now this. Z is divisible by y is divisible by x. That implies z is divisible by.
Divisible by x. Sir, do we have to write this or can we just take an example and explain?
No, you cannot take. See, what I'm saying is, let's say you have taken this example. 2 comma 4 belongs to R and 4 comma 8 is not there, right? So 2 comma
So that's why we can take 1 comma 2, 2 comma 4.
1 comma 2 and 2 comma 4. Let's say you have taken this example, but here if you prove for one, see, you prove for only one case, na, then how can you say it is true for all?
Yes, sir,
Understand?
got it.
So that's the reason you can't take only one example and prove. This is not the way. This yeah, giving this example, but you can show, you can see it for yourself. But this
It's only one
this is
case.
yeah,
Got it.
you proved it for one case. Doesn't mean that it is true for all, no?
Yes, sir.
So that's it. So y is divisible by x. So this is general. You take x comma whatever you want, you can take from A. In A, whatever you want, x, y, z, whatever you take, this is you put here 1, 3, you put 3, 6, you put. Hannah, 3 is divisible by 1 and 6 is divisible by 3, then automatically 6 is divisible by 1. Yes or no? X comma y comma z, you can take whatever you want from A. That's true now. Yes or no?
Yes, sir.
Like that. So that implies z is divisible by x, that is x comma z also belongs to R. Like that. Is that okay?
Yes, sir. So this became reflexive, not symmetric, but transitive. But transitive. Yes, sir. Reflexive,
Yeah.
not symmetric, but transitive.
All right. So let's go for 4. What do you think about 4?
So the fourth one, it's not reflexive.
Okay.
So 1 second. So I think it's all, I'm not understanding this one.
Yes, all. So how do you prove? Okay, that's true. It is equivalence relation. It's all. So reflexive, symmetric, transitive. But how do you prove? You see. Now, whenever you say it is true, then it is true for all, right? All on Z, yes or no?
Yes, sir.
So therefore, you can't take an example and tell that it is reflexive. Yes or no? But you have to prove for general. So how do you prove? See, for every like this, for every x belongs to Z. That means for any integer, for every z x belongs to z. That means what? Whatever element you take from integer. That means for every integer, you are saying for every integer, x minus x. See, for every integer x minus x equal to 0 is an integer.
Yes, sir.
Like this, you should say. You understand this?
Got it. Yes, sir.
Mathematics language. So for every x belongs to z, x minus x is an integer. That implies x comma x belongs to r. For x minus y belongs to r, x minus y r lo undali ante x minus y is divisible. X minus y is integer, na? X minus y integer avute x comma y r lo untundi. Yes or no?
Yes, sir.
So then here x comma x belongs to r because x minus x is 0. X minus x
Yes,
r lo ఉంటుంది ఎందుకు x minus x is an integer. X minus y integer అయితే x comma y ఉంటుంది. X minus x integer అయితే x comma x ఉంటుంది. For every
Yes,
integer,
sir.
that means what? 0 0 is there, 1 1 is there, 2 2 is there, 3 3 is there, 4 4 is there, minus 3 is there, minus 4 is there, like that. Every integer,
Yes.
this. Therefore, what you should conclude? Therefore, R is reflexive. You should write like this. Reflexive. Okay, therefore R is reflexive. Like that you should write. Symmetric. Can you tell them symmetric? How do you write?
So for symmetric, we can write for every x comma y belongs to r, y comma x also belongs to r because that is also an integer.
For every x comma y belongs to R, for every x comma y belongs to R, what you are saying? Y comma x also belongs to y comma x belongs to y comma x belongs to R. Reason you should give. This is true, but why? For every x comma y belongs to R, see x minus
y
y
or y minus x will be
belongs to
integers.
R, x minus y belongs to R, that implies what? Minus of, see, you say, that means what, see, you are saying, yeah, see, for every x comma y belongs to R, what you can say, x minus y is integer, no? That implies what? For every x comma y belongs to R. You are saying x comma y belongs to R, no? What you can say, x minus y is integer, right?
Yes, sir.
That if x minus y is integer, that implies y minus x is
Also an integer.
also integer. This everybody knows. Yes, sir. X minus y is integer, then y minus 2 minus 4 is integer. 2 minus 4 is integer. That implies what? 4 minus 2 is also integer. Yes, sir. No,
Yes.
4 minus 2 is integer. This is also integer. Okay, negative only, na? This is just negative. Okay. So like that,
Yes,
that implies what? Y comma x also belongs to R. We have to start like this. How do you start? Even more appropriately. How do you start? Like this. You should start like this. Let x comma y belongs to R. You should start like this. Why? Because when x comma y is there in relation, then only y comma x you need, na? Now let's assume
Yes.
x comma y. You have to start like this. Let's assume x comma y belongs to R. That implies what? X minus y is an integer. Yes or no?
Yes, sir.
That implies what you can say? Y minus x is
Also an integer.
also an integer. That implies what? Y comma x also belongs to R. Therefore, what you can say? R is
It's symmetric.
This is how you write.
Yes, I got it.
This is how you write. Transitive, what about transitive?
So same thing, let x comma y belong to R, then x minus y is an integer.
No, tell me properly. I gave many examples. No, how do you write it mathematically? Clearly you should. No? How do you begin?
Let x comma y
Let x comma y
belong to R. Belongs
And
to R.
y
X
comma
minus
z
y and y
belongs to
comma z
belongs to
belongs to
R. Belongs
R.
to R. R, yes, belongs to R. This is how you should begin.
Yes, sir. And then we write that implies x minus y is an integer.
Okay,
No, that
integer.
doesn't.
Integer. Right. And this
Y
means
minus
that
z is also an integer.
x comma y belongs to R, meaning x minus y is an integer.
So that's why I said we can take it out also.
No, yes. Yes, integer. Right. Then next, Hannah, this is an integer.
Yes.
This is also an integer. Then we have to prove what
X minus z is also an integer.
How do you know? That's a question. Integer है ना, ये वाला integer, ये वाला integer, ये वाला integer, ये वाला integer, integer plus integer ये होगा, है ना?
Yes, so we can add x minus y plus y minus z
X minus
is equal to
y is integer plus y
plus,
minus
yes,
z. Okay, integer plus
equal to an integer.
another integer.
So
Okay,
the same
that is-
as the first example, we added to prove. Yes, I got it.
Yes, is integer.
Therefore, x comma z belongs to R.
Yes, therefore x comma z belongs to R. This is how you should write properly. That implies now R is transitive.
Transitive. Yes, I got it.
Okay. Right. Okay. So
Yes. Sir. So 1 second. I just. Yes, sir.
now here is fifth question. Fifth bit also has some subbits. Bits, number of bits.
Yes, sir.
Okay, so this one you can see. Relation R in the set A of human beings in a town at particular time. Okay. R equal to x and y, x and y work at the same place. So like that it is somewhat. Okay, anyway. So you can check like this, x and x work
So this
at
is,
the
I
same.
think, all three. This is equivalence because x comma y matlab work at the same place. So I don't know how it's reflective though.
Reflexive.
Sorry, reflexive.
Reflexive means, yeah, x and x work at the same place. See, like that. How do you?
Sir, but that isn't possible.
See,
No, it's a human
if-
being. So there's only one of them.
See, for example, you say, for example, x is a line, like let's say line, set of lines. X comma x belongs to R, you can say, because every line is parallel to, let's say, equal to or parallel to. Every line is parallel to itself. Like that, every person, yeah, see, x and x work at the same place. Every person, you see, like this. Every line is parallel to itself, we can say, but you can't say like this here. Yes or no?
Yes, sir.
So therefore, it's not reflexive. Because there is no question of x comma x belongs to R. Because same person, you can't take twice.
Yes, sir. So it's not reflexive, but it is both symmetric and transitive.
Symmetric x, y work at the same place means y comma
Yes, then
x.
y x will also work at the same place.
Okay. X, y work at the same place, y, z, and then x, z also. Okay, that's
Yes,
like
that's
that.
why it's both.
X and y live in the same locality.
Sir, again, same thing
Same
only,
thing,
but it's
same
not
thing.
reflexive. Yes,
This
sir.
is x is exactly 7 centimeters taller than y. Nothing.
It's not reflexive. It can't be symmetric.
Because no, y equal to simply you can say like this. Yes, sir. This is
Y is
y.
equal to x plus
Exactly.
7.
This is the relation here. So when this relation is there, this is neither reflexive nor symmetric nor
Not
transitive.
transitive. Yes, sir.
Oh, x is y part y. This is also nothing. X is y part itself. X is y part itself. X comma x means x is y part x only. That's not possible.
Yes, sir,
X
it's not
is
possible.
x
It
is
can't be
x.
symmetric also.
Yeah.
Because Y can't be the wife of X. Y will only be the husband of X. If
Okay. And also transitive
transitive,
also. Not
it's not
transitive.
transitive. Yes.
Same thing. Somewhat funny.
Yes, sir. So even the last one is the same. There's no harm.
Yes.
Father.
Yes. So now you consider this second is important and fifth is important. Yes. So second, show that the relation R in the set of real numbers. This is capital. You saw this is R small. This is not bold. In bold letters, right? Somewhat dark, yes, sir. Generally,
Yes,
it
sir.
is.
So your voice is very low suddenly.
Okay, so suddenly very low.
Yes, sir. Now it's better.
Okay. Have to see.
It's obviously transitive.
All right. So, is neither reflexive nor symmetric nor transitive. So, you only gave what we should do when it is not reflexive. What? How do we prove? How do you prove when it is not? Prove by counteraction. This is one of the way you prove. Disprove. Disprove. Okay, whenever you have to disprove, you have to give counterexample. Is that okay?
Yes, sir.
So you have to give now. It's not reflexive. 2 comma 2. Simply you give 2 comma 2. Does not belong to ho gaya na? This is enough, right? Does not belong to R. As 2 is yeah. This is, see, this is 2 comma 2 belongs to R. Yes, sir. Why? Because this doesn't work because this is true only, right? Either less than or.
Yes, sir.
Okay, here, then give an example. This does not work. So give another example. You give example. Yeah, tell me. So see here, yeah, A is definitely less than or equal to B square. Square, na? A is A comma A belongs to R. Implies what, A is definitely less than A square. Yes or no?
Yes, sir.
But in some way it is because here all real numbers hai na. A is for any integer, this is okay. For integer, it's okay. Hai na? Integer 1, 2, 3, 4, it's okay, but it's not okay
Yes,
for
sir. For
what?
fractions.
Exactly 1 by 2,
Yes, sir.
1 by
1 by
2
2, 1
does
by even
not belong
yes,
to.
sir. Got it.
Yeah, understand. You told, na? Already you told, correct. After you told only I am writing.
Yes,
Is
sir.
equal to 1 by 4 is false.
It is false. It's not true.
Like this. Like this, you have to give example. Okay.
Yes, sir.
That means if you are able to give one example, that means you know many examples.
Yes, sir.
Right. So symmetric. How do you prove symmetric? Not symmetric. How do you prove not symmetric? This is not symmetric is very easy. So let A comma B
Yes, sir. We take
belongs
9, 3,9.
whatever.
We take anything. It will be,
Anything can take. 1
then
comma
nothing will
2.
be symmetric.
Yes, 1 comma 2 belongs to R for sure.
2,1 does
Yes.
not belong to it.
Yes. But 2 comma 1 does not over, not symmetric. Transitive, not transitive. This is little Kafka. Little Kafka. Not transitive, little Kafka. Because generally it looks like now A less than or equal to B square and B square, B less than or equal to C square. है ना? A comma B
Yes.
belongs to R, B comma C belongs to R. So what is this? A is less than or equal to B square and B is less than or equal to C square. Okay, then A is less than or equal to C square. Mostly it will happen. But where it doesn't happen in this.
So again, I think if we take fractions, we might get it.
Fractions. This should happen. Fractions
Again, that is only not satisfying it. Yes, it's not possible for fractions.
Yes. You reply. That's what that's the reason I told. Second question. You will try for next class.
Yes, sir. I'll try.
Okay. Anyway, so now I think you had examples. Okay. So by next class you can finish off. By next class you can finish off this one.
So your voice is again very low. I'm not able to hear you.
Okay, you are able to hear now?
Yes, sir.
You are able to hear now?
Yes, I can hear you.
Okay. I don't know what is the reason why. 100%
So
is
for the
there,
next
but
class, sir, should I finish, right? Try to finish the entire exercise.
entire exercise it takes only 15-20 minutes.
Yes, it's not difficult. So yes, sir.
But you have to send me tomorrow only.
Yes, I'll send it tomorrow. Pakka.
We'll have class at 4:30.
So, is it possible by any chance to have it in the morning? If it's not possible, then 4:30 is okay. But otherwise,